Hello everyone. Today is the 13th day of Leetcode 75 challenge. Let's begin with the 13th question. Question 1679. Max number of k-sum pairs. The level of the problem is medium. I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler way. Now let's understand the problem in easiest way possible. So you have been given an integer array nums, let this be the array, and an integer k. You need to find the maximum number of pairs of elements whose sum equals k. Okay, so we have to find maximum number of pairs uh, and whose sum is equals to k. Fine. After finding a pair, remove those two elements from the array, and we have to return the maximum number of operations we can perform. Right. So basically, if we have some numbers here and k it has some value x, so they are saying that we need to find maximum number of pairs of elements sum equals k. So for example, let 1 plus 3 equals to x. So this is one pair. So after finding that pair, you have to remove those pairs from the array. So after finding it, we will remove it. Okay. And again, we have to find, let's suppose 4, 6 is also equals to k. So we got total two pairs, right? And this 4 and 6 will also get removed. So this is what the question is asking, that we have to basically find two elements or pair of elements whose sum equals to k, and we have to remove it from the array. That's all. I hope you understood the problem explanation. Now let's move to the constraints. The length of the nums array will be from 1 to 10 to the power 5, and the value of nums array could be from 1 to 10 to the power 9, and value of k could be 1 to 10 to the power 9. Okay. Now let's move to the next slide. Now let's understand the input output explanation. Let's understand here. So we have been given 1, 2, 3, and 4, right? And k is 5. So k equals to 5, right? So we can say that, see here, 1 plus 4 gives us 5, right? So we got one pair. According to question, we will remove this. Okay. Then 2 and 3, if we sum them, we get 5 again. So total number of pairs are 2. That's why the output is 2 here. Okay. Here. Um, k is 6, right? So 3 plus 3 is also 6. Or 3 plus 3 is also 6, right? So our wish, whichever we could take. Let's take this one. So we are left with the, we write it here, 3, 1, 3, 4, 3, right? And k goes to 6. So we took these two threes, right? So after taking these two threes, we are left with only 1, 4, 3. So now we can't find any value equal sum equals to 6, right? Any pair. 1, 4 gives 5, 4 gives 4 plus 3 gives 7, and 3 plus 1 gives us 4, right? So and our output for this array will be only 1, right? This is output. So I hope you understood the input output explanation. Now let's move to the next slide. To understand what problem is asking, we should build up an intuition to the problem. Fine. So we could take the example for building the intuition as imagining we're buying snacks. Let snacks be chips. Let it be chips we are buying, and let it be chocolate. Okay. We have some coins with different values or different denominations. Let's understand that. And you want to buy snacks that cost exactly 10 coins. For example, if the price of the chips is 10 and price of the chocolate is also 10, so you are only allowed to buy chips or chocolate or any other item of rupees 10 only. Fine. You need to combine two coins. You cannot just use one coin of 10 and just buy anything. You need to combine two coins, make a pair of it, and buy it. Once you use two coins, they are gone. You cannot use them. Your goal is to buy as many snacks as possible. So, what is this? What we can come up with the example is that you have coins of different denomination. Let's go like 1, 2, 4, let it be 8 also. Okay. So this is the denomination you have. Using this denomination, you have to buy the item. Now, it's a normal understanding that whenever we buy something, the value which we give to the shopkeeper, it get reduced from our side and incremented in the shopkeeper side, right? So this is the same thing which is asked in our problem. So from this example, or let's build up an intuition. So let's say we have some coins with us. Let it be 2, 4, 2, 5, 5, 8, 1, comma 1. Fine. This is the coins which I have right now. Now the thing is, what could be the total sum? 4, 5, 6, 7, 8, 8 plus 8, 16, 17, 18, 18 plus 10, 28. Okay. Hmm. Now let's focus. What would be the best thing which we can do? We cannot just take two maximum values and give it to the shopkeeper. Neither taking two minimum coins values like 1 1 and give it to the shopkeeper. We have to mix it, right? The combination should be a mix of greater and smaller element. So what if we take the smallest element? In this case, we have 1, and take a greatest element. At least let it be 8. Okay. So now in our hand we have a pair of 1 plus 8, which is 9. Okay. So this value is less than the value required to buy the chocolates or snacks. So what we can think of? Okay, we have 8 as a maximum value right now with us. Fine. The only option left is that let's try a value which is not 1 but greater than 1 and less than 8. What could it be? It is 2 in this case, right? So we take 2 plus 8. It comes out to be 10. Yes. So we are able to buy one packet of chips. Now, since we have given that money to the shopkeeper, this 2 will disappear from here. 8 will also get disappear from here. Okay, this is done. So we have given the pair of 2 comma 8 right now. Okay, this could be the understanding. Now let's take example of we have more money left with us. So if we take 5 and 5, we get 10. So we are able to buy the item. Okay, fine. This is also understand. If we have the same value, which is half of the given value, if we take those two values, then it results in the output. So we have another pair of 5 comma 5, and it got removed from our wallet. Okay, this is done. Now there could be a case. Let's assume we have one more 8. Let's add one more 8 to our array, right? And let's remove this 2 from here. Let's consider one more case. Let this instead of 2, let it be 3. Okay, and let it be 2. Now there could be one more issue that we took take 8. Okay, then we tried taking the smallest value, which could be 3. Fine. What happened? 8 plus 3 gives us 11. Okay, it is greater than 10. But since you can see that one value is greater than the required value, and we don't have any value smaller than, let's remove this 2. Let's assume that there is no value less than 3 with us. But we have 7 denomination also. I'm just adding the values right now in the array to make a case for us. So please try to understand. Okay, I'm making a case on the spot right now. So yeah. But I can see that okay, 8 plus 3 cannot be used, and 3 was the smallest value. Let's assume we don't have 1 anymore with us. Even if we have, we cannot use them, right? Okay, so what we can do? We can reduce the maximum value which we have to some less value than compared to it. So we try taking 7. So it becomes 7 plus 3, which turns out to be 10. Sorry. So it requires to our output. So we got 3 pairs, 7 comma 3, 5 comma 5, and 2 comma 8. Okay. So what we understood from the intuition, we understood that if the sum of the taken pairs is equals to the k, which is 10 in this case, buy the snack and remove those coins, right? If the sum is less than the k, in the case of 1 plus 8, right? Try the next bigger coin. Next bigger coin means from the smaller end. If the sum is greater than k, like in the case of 8 plus 3, try the next smaller coin. In case of 8, so it will be 7 plus 3. In this case, 2 plus 8. If keep now we keep adjusting until we have tried all the possible pairs, right? And at the end, when we are done with the array or iterating the array or searching in our wallet, we just return that how many pairs we have created till now. I hope you understood this example, how it is working. Now, how we gonna solve this? We understood the intuition is this. How we gonna solve it? Here comes the concept of two pointers. Yes, this question is also related to the concept of two pointers, but along with two pointers, there is one more concept is used there, which is, let me write it down, two pointers. Okay, but let's give the second part a hold right now. But there is a problem using only two pointers. The problem is if the array values could be inconsistent, right? It could be increasing, it could be decreasing, or it could be same, right? In this case, we can get confused which value to be taken. Like if taking this value and this value might result in some array answer, right? But previous value was not able to relate with any value still here to make any pairs. But this value and this value were able to make some pairs, right? So we will miss this value pair and this value pair, right? So that we don't come run into that kind of situation, we have to sort the array. Since the question does not ask us that require the whatever the direct, since the question does not says that the relative order should be maintained, we should sort the array. After sorting the array, we get in increasing order, we get a sequence, right? This makes our work easier to solve. So this question is solved using two pointer plus sort, right? Since we are using smallest and largest coins first, right? So this could be done using two pointers, left and the right. I hope you understood why we are using two pointer and sorting algorithm and how we came to the conclusion of using those two. So now let's move to the next slide. Before going to the approach, let's understand what this two pointer concept is. Two pointer is a technique where we use two different variables, which will be pointers obviously, and to traverse an array, string or linked list efficiently instead of using nested loops. Okay, how it works? You place two pointers at different position. The common one is starting position of the array and the ending position of the array. Okay, move the pointers towards each other in a specific direction based on the conditions. So we have to move pointers to each other based on the conditions where they're going to be terminated. And this also helps in reducing the complexity from move n square to n. So there could be some conditions in which, let me be more clear to you. There could be conditions where we are traversing in O of n scenario, right? For loop is there and another for loop is within it, right? But if we have to convert that n square approach to O of n, we could use two pointer in that case. If this is the array, right? We could place I here and we can start j from here or from here also or from here also. It is not mandatory that always j and I will start from start and end. The position could be anywhere. But the thing is that it should work in such a way that it reduces the complexity from O of n square to O of n. There could be one more case like this. You're starting from here and going this side and this side, right? So this is what this two pointer is all about. Basically, we try to convert O of n square to O of n, first thing. Second thing, if we have any question like where traversing in a single point is manageable, we use two pointer there. And places where we use two pointers could be sorting and searching when dealing with sorted arrays to optimize search operations, linked list for detecting cycles, Here we use the concept of fast and slow pointers, which we will study when we will solve the questions based on linked list and finding the middle or reversing efficiently. In string manipulation, when modifying or comparing or checking conditions on a string, in sliding window is the most important one to use two pointers for finding sub-arrays or substrings for specific properties. Two arrays processing, which we are doing right now, and merging, comparing, or finding intersections of arrays, and greedy and optimize when solving problems that require scanning from both ends. As I said, we can go from here from start and beginning. Okay. I hope you understand why we are using two pointer concept and how it is done. Let me give you one more small example. Like if we have this sorted array and we have to find some, say, five, right? Not five. Let it be four, and let it be five. Okay. Now we are asked to find a value as 2 plus 5, 7, right? Okay, we have to find 7. Optimized way using two pointer would be we will start from start and one from beginning. We add these two values, we get 6. So from here we could understand that 6 is less than 7. So what we will try to do, try to move the left pointer towards right. 2 plus 5 we get 7, so we got our output. And this could be same done in the O of n square opportunity complexity by traversing start keeping index 1 and traversing this complete array, then keeping this as 1 and traversing this complete path. So yeah, so this is one of the examples I could take right now for understanding of the two-point concept. I hope you understood it now very clearly. Now let's move to the next slide. Now, since we got the intuition of the problem, let's look into the approach, how we're gonna solve it. Okay, let's put in mind that we are using two pointers plus sorting. Okay, we will first store the length of the nums array because we will be iterating, right? That's why we'll be requiring this. Now we will declare two pointers, one starting from the zeroth index from the beginning, and one from another one starting from the end, right? And we will make a count variable which will store the maximum number of valid pairs still found till now. Fine. Now let me now the thing is why we are using two pointers, right? And sort both together. We use sorting because it is the only way to get the smallest and the largest value in ordered manner. Once the array is sorted, you can easily check the sum of smallest and largest values. The if the sum is less than the target, right? It is obvious that you need a bigger value. So you move the left pointer to the next larger element, and since that's not only way the sum can increase, since similarly if the sum is greater than the target, you need a smaller value. So you move the right pointer to the next smaller element. Without sorting, you wouldn't know where the smallest and largest values are. You had to have searched randomly, which would take forever, right? This will also increase the complexity of our problem, right? Since we know the smallest element is here and largest element is here, we can take out the sum very easily, right? After declaring this variable, now let's move to the next slide. Now we start a loop to find pairs while I is less than j, right? Unless I and j process each other or meets each other, right? If the sum of the elements are same equals to the k, right? We found a pair. We will increment the count and we will increment both I and j. I will be incremented toward right side and j will be decremented toward left side. If nums of I plus nums of j is less than k, now since we have sorted the array already, right? So it will be easier for us to move the I pointer towards right side to find a bigger value. Sum is too small, right? So we need a larger value to reach k. We increase the left pointer to try a bigger element, and similarly, if the sum is greater than k, the sum is too large, therefore we know that it's problem of the j pointer. So we will reduce the j pointer to the next smaller element. This is how the loop will iterate. Now it comes to our mind why two pointers and how it removes the pair. Now focus on this. If the sum of the smallest and the largest value is less than the target k, it is clearly means the smallest value is too small to reach k even with current largest value. In this case, The only way to increase the sum is to look for a larger value, which means moving the left pointer to the next larger element. On the other hand, if the sum is greater, so we move the right pointer to the also left side, right? We have to decrease the sum in this case. And after that, one controls the smaller side and the other controls the larger side. The I controls the smaller side, J controls the larger side, right? And this, and whenever the I moves ahead and J moves ahead, it is basically removing the characters from the array. We are assuming it that values are getting removed from the array. When the sum of I and J becomes equals to K, we increment and decrement both. So we have used those values and we have removed them, right? And when I is only incremented towards right side, we know that that value is not of any use. So we remove that discarded value and move towards the right side. Similarly with J also. I hope you understood the conditions of the loops, how it is working. And at the end, we return the maximum count which was stored in the variable CNT. I hope you understood the approach. Approach is very easy. There is nothing to worry about. It was that it was just that we have to understand the intuition, which I tried my best to explain it, and why and how we come to the point two pointer concept and the use of sorting also. Now let's move to the next slide. The code is the exact copy of the approach discussed. Let's understand it line by line. We declare the n variable to store the length. Now we sort the given array. One of the concept is done, sorting the array. Okay, one task is done. Now I equals to 0 and j starts from n minus 1. This basically is that I will handle the smaller part or smaller elements and j will handle the larger element. And count will store the maximum count. While I is less than j. Okay, this is the same thing. If the sum of them becomes equals to k, we increment I, decrement j, and count plus 1 is done. If I is if the sum is less, right, then we increment I. If the sum is greater, we decrement j, and at the end we return count. That's all. The code is very easy to understand. Now the complexity n log n. N log n time complexity comes from the sorting algorithm. Most of the time, sorting algorithm uses merge sort, which is of n log n time. Fine. O of n, this comes from the iteration part, from the while loop. But adding them gives us O of n log n because it is a bigger element compared to O of n. That's why time complexity is n log n. Space complexity is O of 1 since we are not using any extra data structure to store the values. I hope you understood the code and the time complexity and space complexity. Now let's move to the next slide. Now, since we have the understanding of the code, let's look at the dry run of the example. Fine. Okay. Let me write it here. 1, 2, 3, 4, and k equals to 5. Okay. Our I starts from 0. J starts from n minus 1. And we sort the array. In this case, the array is already sorted. So it's done. First thing is done. Now, while I is less than j. Fine. I is here. J is here. Our first condition was if n nums of I plus nums of j equals to k, we increment I and decrement j, and count variable also gets incremented. Fine. Now count is 0. Now adding, now in this case, yeah. So if we add 1 plus 4, we get 5, which is equals to k. So we increment I and we decrement j. And our count from 2 becomes 1 since this condition is fulfilled. Right. Again, I and j are here, and the sum becomes 5 again. Again, from count becomes 2 and they process each other. So the while condition gets falsified and it returns count as 2. Okay. Now let's take another example and understand the dry run more in depth. Okay. Uh, in the corner, I will try to write down the condition. Okay. First condition was I'm writing it in this way: I plus j if j equals to k, it will be I plus plus and j minus minus and count plus plus. Fine. If I plus j, if it is less than k, just I plus plus. If I plus j is greater than k, then j minus minus. Okay, these are the conditions. Now let's look here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. This is the given array. It is not sorted right now. Right? Now look here, k is 10, right? Now, by just sorting the array, we could clear that thing right now in this example also. For example, if we have started from here, right, we could have seen that no, they are not equal, right? So what we do, randomly we just try to find a value which is equals, which makes this 10, right? So we got 9, 9 plus 1, 10. Great. But this is done. Now we got here, let's take is 5, right? And we have to make 10. Let it be 7, one more part. And somehow we reached at 2, right? 7 plus 2 is 9. And we tried to search another element. We got 4. So in this case, what happens is that we missed the value 3. This is a situation which can come up while iterating. That is the reason we try to sort the value in beforehand. Okay. Now let's sort it. The sorting it becomes 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. I starts from here. J starts from here. Okay. I is 1. J is 9. Okay. So 1 plus 9, 10. So we got count 1. We increment both. I comes here. J comes here. Now in this case, we can see that 1 plus 8 is less than 10. So of course, we will be incrementing I now. Now from I becomes 2, right? The value of I is 2 now. So it becomes equals to 10. Fine. So count becomes 2. So we increment I here also and we decrement J. Again, we can see that 7 plus 3 gives us 10. So our count becomes 3. And we increment I again and J again. Again, in this case, we are getting 4 plus 6 equals to 10. So our count becomes 4 again. We increment both. I comes here, and since J also comes here, it falsifies the condition of I less than J, and we return count. So our output becomes 4. So I hope you understood the dry run. Now, if you have any doubt in the concept or in the logic, how we end up using sorting and two pointers, I will request you to go through the intuition again, then the approach, and understand how two pointers work, and take 2, 3 examples of your own and try to do the dry run on it. I'm pretty sure you will be able to understand how we arrived in this solution. Now let's move to the next slide. Now, since you are familiar with the problem and solution, let's move to the lead code and code the solution. N equals to length of nums dot sort. We will be sorting the array. Sorting nums. Then I equals to 0. Left pointer. J equals to n minus 1. array point count will store the count of pairs while I is less than j. If nums of I plus nums of j equals to k, what I will do? I plus 1, j minus 1, and count plus else if nums of I plus nums of j less than k, what we will do? We will increment I, else we will decrement j. At the end, we will return. Our other test case got passed. Now let's submit the solution. We have successfully submitted our problem. Now the code of the problem is available in my GitHub repository. You can find the link in the description. Thank you everyone.